Now before I talk about the root test, I just want to talk about the previous video. Now I apologize for making a small mistake. I said for the ratio test that the limit as n approaches infinity, we're going to test the limit of a sub n plus 1 over a sub n. Now what we're actually doing is taking the absolute value. So in the previous video I forgot about the absolute value and I apologize for that, but this is really what you're taking the limit of. And what that absolute value basically means is you're just going to take away the alternator. So if you do have an alternator, like let's say you have the series of negative 1 to the n over 3n plus 1. Basically what the absolute value means is you're going to take away the alternator, so don't even worry about that, and set the limit to whatever's left. So the limit as n approaches infinity of 1 over 3n plus 1. So let's take a look at the root test now. So the formula for the root test, let's say we have the series from n equals 1 to infinity of a sub n. What we can do with the root test is set the limit as n approaches infinity of the nth root of the absolute value of a sub n. And let's say that limit is equal to a value L. Now the root test is very similar to the ratio test in that if L is less than 1, like the ratio test, the series of a sub n will converge and is absolutely convergent. If L is greater than 1, obviously the series is divergent. And if L is equal to 1, exactly equal to the value of 1, then it is inconclusive. And we need to try another test. And once again, when we're talking about the absolute value of a sub n, we're just going to take away the alternator if there is one in the series. So once again, if there's a negative 1 to the n power over, if we have the series of negative 1 to the n power over 3n plus 1, we're going to take away that and just worry about what's left, which is 1 over 3n plus 1. And we're going to set the limit of the nth root of that value. And keep in mind that the root test requires a little bit of creativity and some algebra techniques. So for number 1, we have the series from 1 to infinity of n squared plus 1 over 2n squared plus 1 to the n power. Now once again, with the root test, we're going to take the limit as n approaches infinity of the nth root of a sub n, of the absolute value of a sub n. And we don't have an alternator in this sequence, so we don't need to worry about the absolute value. We're just going to take the nth root of what we have here. So the limit as n approaches infinity of the nth root of the entire thing, so n squared plus 1 over 2n squared plus 1, all to the nth power. And notice how the nth root and the nth power will cancel. So let's say we have the square root of x squared. The square root of x squared is just equal to x because the square root and the squared will cancel. Or if we have the 10th root of x to the 10th, the 10th root and the 10th power will cancel and we just get x. So same applies here. When we take the nth root of some value to the nth power, the n's will cancel and we're left with just what's inside. So if I were to rewrite this, the limit as n approaches infinity of n squared plus 1 over 2n squared plus 1. Now once again with n behavior, we're looking at the highest degree of the numerator and the denominator. The highest degree of the numerator is n squared, and the highest degree of the denominator is 2n squared. Since they are the same degree, we're just going to look at the ratio of the coefficients, and the ratio is 1/2. So the limit as n approaches infinity is 1/2. Notice 1/2 is less than 1, which means the series is absolutely convergent by the root test. So for number 2, we have the series from 1 to infinity of n to the nth power over 3 to the 1 plus 3n. Now, once again, for the root test, we're going to take the limit as n approaches infinity of the nth root of the absolute value of a sub n. Now, obviously we don't have to worry about the absolute value right now because there is no alternator in this series. But if we do take the nth root right now of this series here, it's going to be very difficult to simplify. So we have to find a way to put this fraction, this entire fraction, to the nth power, so that when we take the nth root, they will cancel and we'll get just what's left inside, and it'll be easy to take the limit. So this requires a little bit of algebra here. So if I were to simplify, or if I were to expand this bottom denominator using the properties of exponents, I can change it into, so 3 to the 1 plus 3n. Since there's a plus here, we're going to multiply. So I can expand that into 3 to the first times 3 to the 3n. Because once again, when we multiply of the same base, we're going to add the powers. So we're going to end up getting the series from n equals 1 to infinity of n to the n over 3 to the 1 plus 3n, which has been expanded to 3 times 3 to the 3n. Now, since 1/3 is a constant, I can take that, just like integrals, I can take that outside of the series. So I'll rewrite this as 1/3 times the series from 1 to infinity of n to the n over 3 to the 3n. Now I can actually expand this even more, because I can rewrite 3 to the 3n as 3 cubed to the n power. Because whenever you have a power to a power, you will be able to multiply the powers. So then 3 to the 3 to the n power is just the same thing as 3 to the 3n. So then I can rewrite it as n to the n over 3 cubed to the n power. Now notice how we have similar exponents on the numerator and denominator. So I can actually factor out that exponent. So we have n over 3 cubed all to the n power. Once again, if I were to distribute this exponent, we have to distribute it to both the numerator and the denominator, and we'll get back to where we started. So this is a legal move. 3 cubed is obviously 27, so I'll just rewrite it as n over 27 all to the nth power. And now I can use, once again, the limit notation. So the limit, as n approaches infinity, of the nth root of a sub n, and a sub n is obviously n over 27 to the nth power. Notice how the nth root of something to the nth power will cancel, so we'll get the limit as n approaches infinity of n over 27. And obviously when we plug in infinity for n, it is going to be top heavy, so it's going to go diverge to infinity. And don't forget, we do have that 1/3 that we factored outside the series, so if you want to factor that in, you can. We have infinity times 1/3, but it doesn't matter because that'll still equal infinity. Infinity is greater than the value of 1, which means the specific series will diverge by the root test.